In this video, we will discuss the law of cosines. In some cases, our given information does not allow us to use the law of sines. For example, if we only know all three sides of a triangle, we cannot use the law of sines to find the angles. In a case such as this, however, we can use the law of cosines. This law is based on the trigonometric functions such as the law of sines is. Law of cosines. The square of any side of a triangle is equal to the sum of the squares of the other two minus twice the product of the other two sides and the cosine of the angle opposite the first side. That is, for triangle ABC, a squared equals b squared plus c squared minus 2bc times the cosine of a. B squared equals a squared plus c squared minus 2ac times the cosine of b. And c squared equals a squared plus b squared minus 2ab times the cosine of c. To use the law of cosines, we need three sides of a triangle or two sides and their included angle. We can sometimes use either the law of sines or the law of cosines to solve certain triangles. However, when possible, the law of sines is generally preferred because it involves fewer calculations. To find the unknown parts of an oblique triangle given three sides of the triangle, first, substitute the known values of the three sides into any version of the law of cosines. Second, solve for the unknown angle in the version of the law of cosines selected in step 1. Third, repeat steps 1 and 2 using a different version of the law of cosines and solving for the different angle. Or use the angle measure found in step 2 and find a second angle using the law of sines. This second option is much easier. And fourth, find the third angle of the triangle by subtracting from 180 degrees the sum of the two angles found in steps 2 and 3. Find the angles in triangle ABC in the figure below. Find A. A squared equals b squared plus c squared minus 2bc times cosine A. So cosine A equals negative a squared plus b squared plus c squared over 2bc, which is equal to negative 7 squared plus 8 squared plus 5 squared divided by 2 times 8 times 5, which equals negative 49 plus 64 plus 25 over 80, which is negative 40 over 80. Sorry, that should have been positive 40 over 80. Sorry about that, which is 0.5. So A equals the inverse cosine of 0.5, which is 60 degrees. Now we find B, and I'm going to demonstrate two ways of doing this and show that they give the same result. First, we'll use the law of cosines, then the law of sines. Using the law of cosines, we get b squared equals a squared plus c squared minus 2ac cosine b. So cosine b equals a squared minus b squared plus c squared over 2ac, which equals 7 squared minus 8 squared plus 5 squared over 2 times 7 times 5, which is 49 minus 64 plus 25 over 70, or 1/7, which means that b is the inverse cosine of 1/7, which is 81.7867893 degrees, which is about 81.8 degrees. Using the law of sines, I set up my proportion. A over sine A equals B over sine B, and sine B is equal to B times sine A over A, which equals 8 times the sine of 60 over 7, which is 4 root 3 over 7. So B equals the inverse sine of 4 root 3 over 7, which is equal to 81.7867893 degrees, which is, again, about 81.8 degrees. Either way, the value of B remains the same. And now we find C. We could use the law of sines or the law of cosines to find C, but the easiest process is just to add the values of A and B and subtract the sum from 180 degrees. So C equals 180 degrees minus A plus B, which is 180 degrees minus 60 degrees plus 81.8 degrees, which is 180 degrees minus 141.8 degrees, which is 38.2 degrees. Notably, the book uses the longer estimate of the measured angle of B, but the final answer is exactly the same when rounded. Find unknown parts of an oblique triangle given side angle side. The law of cosines is needed to solve oblique triangles if two sides and the included angle are given. To find the unknown parts of an oblique triangle given two sides and the included angle, first find the side opposite the given angle using the law of cosines. then use the law of sines to find one of the two unknown angles. We could also use the law of cosines, but law of sines is easier. I think the book may use the law of cosines here, but I'm going to use the law of sines, but because I'm a mathematician. And mathematicians like doing things the easy way whenever we can. And finally, find the third angle by subtracting from 180 degrees the sum of the two known angles. Solve triangle ABC if A equals 42 degrees, B equals 5, and C equals 6. First, we find side A. We know that A squared equals B squared plus C squared minus 2BC cosine A. We plug in the values to get that's A squared is equal to 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of 42 degrees, which is 25 plus 36 minus 60 times the cosine of 42 degrees, which gives us 25 plus 36 minus 44.588,68953, which is 16.41131,047. Take the square root of both sides to get A equals 4.05108756, which is about 4.051. Now we can find angle B using the law of sines. This gives us A over sine A equals B over sine B. So sine B equals B times sine A over A, which is 5 times the sine of 42 degrees over, using the longer form here, 4.051058566. And that's about 0.8258653,947. So B is equal to the inverse sine of 0.8258653,947, which is 55.67632,739 degrees, or about 55.7 degrees. Then C is 180 degrees minus A plus B, which is 180 degrees minus 42 plus 55.7, which is 180 degrees minus 97.7, which gives us 82.3 degrees.